let's get started. I am Manchit, and I'm a senior data scientist at Delivery Hero. Previously, I have worked as a data scientist in the fashion e-commerce domain, and I have three publications to my name till date. Uh, yeah. So this session will be all about evaluating recommendation systems, but before we dive deep into it, we will first get to know what are cross-selling recommendations, why do we need to evaluate these recommendations, followed by what is offline evaluation and how can you go with an online evaluation. Um, in the end, we will also talk about how can you offline decide the best recommendation algorithm, followed by conclusion. So talking about cross-selling recommendations, these are some of the examples of cross-selling recommendations. For example, complete the cart. Given a product in the cart, we can give recommendations such that we aim to complete the cart. Uh, Also, I think I missed mentioning that Delivery Hero is a food and grocery delivery platform. So that's why we have all the food related items here. Yeah. Another example of cross-selling recommendations is from similar product recommendations, where given a product, you can recommend similar items to the user. And last but not the least, an example from complementary product recommendations. Given one product, you can give products that go well with that product. One differentiation between complete the cart and the rest of the two are that there can be more than one products in the cart when the user lands on the cart page. And then you have to give recommendations based on all those products. But for similar and complementary, it's given with respect to one product only. In terms of why cross-selling recommendations are done, there are some pointers. So they help users discover the large number of products on the platform, which thereby reduces the choice paradox. We can also improve user satisfaction by increasing personalization, and it can also reduce the time taken to place the order. So why do we need online evaluation? First of all, online evaluation is done to understand the impact of a feature or model launch on the business metrics. These business metrics could be user conversion, revenue per user, or whether we are also giving personalized recommendations or not. But they are limited by the time, number of users on the platform, and we can often expose the business metrics and user experience to a risk. And that is why offline evaluation can be done to alleviate these limitations of A/B test. Offline evaluation gives approximate impact and could be impacted by the bias in the data, but it is also possible to evaluate multiple algorithms in a short amount of time by changing the model, the feature sets, the hyperparameters. But offline evaluation does not always align with the online A/B. That's what this meme is trying to say. Now let's dive deep into how offline evaluation can be done for different use cases. This is an example from the cart. So given the products in the cart, user preferences, and time of the day, we have a gradient boosted decision trees model, which can rank the candidate items from the restaurant's menu uh, and give recommendations. So these candidates are all the products in the restaurant's menu which are live, except the products which are in the cart. So given these recommendations, we also have some ground truth, which is the actual products that were added to cart by the user. Upon comparing these recommendations with the ground truth, we can compute the offline evaluation metrics like NDCG or mean reciprocal rank MRR. Another example from similar product recommendations. So given the product clicked, user preferences and time of the day, we have a neural network that can rank the candidate items. So in terms of similar product recommendations, candidate items are products belonging to the same category of the clicked product. And similarly, this neural network is capable of ranking these products based on all this information. And then we get those recommendations. These recommendations are then compared with the ground truth. Here, the ground truth is products belonging to the same category of items and that were browsed together. On comparing these recommendations with the ground truth, we can get the offline evaluation metrics like hit rate. Now let's talk about the typical offline evaluation metrics, as I mentioned before, NDCG and MRR. So given this example, we have a query product or items in the cart. And let's say these were the recommendations at position 1, 2, and 3, out of which Coca-Cola was actually clicked. And we also recommended it in the second position. Using this information, we can compute NDCG, which is defined as the ratio of discounted cumulative gains and ideal discounted cumulative gains. So since we recommended it on position 2, the DCG will be calculated as such. And the ideal DCG is that we would have recommended it at the first position. So when we divide DCG by IDCG, we get NDCG. Then the mean reciprocal rank measures how far down the ranking the first relevant document is. Since we recommended it at the second position, we just take the inverse of the rank to give MRR value of 0.5. Apart from the typical offline evaluation metrics, we can also create custom offline evaluation metrics to decide the best cross-selling recommendations algorithm that caters to our business objective, which is the average basket value. Average basket value is defined as the sum of orders value divided by total number of orders. So given the same example, in this case, let's assume that the user added to cart the third double burger, like the recommendation on the third position, which is this double burger. And when these recommendations were shown, let's also assume that after adding the double burger, the user also removed the existing product in the cart. So it's like a substitution case. So given all this data, and let's say these were the price of these products, we can compute some custom offline evaluation metrics like the cart value impact, which is a percentage change in the cart value. So here in this example, we see that the new cart value is 6 euros because this one, the existing product was removed. The old cart value was 5 euros. And when we have this information, the cart value impact at 3 is 0.2. So at 3 means that we are considering the top 3 recommendations. Similarly, upsell at 3 would be is defined as if the value of the products added to cart is greater than the value of products removed from cart, upsell is equal to 1, else it would be 0. So since 6 is higher than 5, here we see upsell at 3 is equal to 1. And then downsell at 3 here is 0 because the price of the product added is greater than the price of product removed. So these additional metrics can help us cater to the business objectives. Now let's talk about how do you design an A/B test, like an online A/B test. There are some basic principles. First, we have to choose the metric right before the starting of the experiment, which involves choosing only one primary metric, for example, the revenue per user, and one guardrail metric, for example, the user click-through rate. After that, we can estimate the sample size based on the significance value, the power of the test, and the minimum detectable effect. Once we have estimated the sample size, we can start the A/B test. And once that sample size is reached, we can compute, we can actually stop the test and compute the significance based on the primary metric. Now, based on the primary metric, we can choose the test as well. So the type of test, there are some types of tests which we'll talk coming forward. They will depend on the type of the primary metric. Once we have made our conclusion, we can roll out the winning version if if the impact was positive or and significant. Else, we don't roll out the version. Now, some things to note here that we will have to choose user level metrics only, like the revenue per user, the user click-through rate, as user is the randomization unit at which bucketization is done. So when we are comparing our two versions, let's say we have a gradient boosted trees model, and then let's say we have a neural networks model as the recommendation algorithms. Um, and let's say if we are comparing them, since we are dividing users into control and variation buckets, it makes sense to only use the user level metrics. And hence, we should not measure significance based on sessions or action level metrics. So the sample size depends on certain parameters. For example, let's say the standard deviation. So if the standard deviation in the data increases, the sample size would also increase. If the minimum detectable effect decreases, then the sample size would increase. Um, and here it's like this is an example from one of the online sample size calculators, which can calculate minimum detectable effect uh, either in absolute terms or in relative terms. So this is nothing but the percentage change in control and variation which you are trying to detect. And it actually depends on the base conversion rate as well. Thirdly, the significance value. So as the significance value increases, the sample size increases. And last but not the least, the power of the test, or beta, like the 1 minus beta is power of the test. If we increase the power of the test, the sample size will also increase. Now coming to which type of test to choose. For conversion related metrics like the add to cart rate and order share, we go ahead with the z-test. For continuous types of metrics like the average basket value, we go ahead with the t-test. And for continuous zero inflated metrics like revenue per user, we go with the two-part test. Talking about what is a zero inflated metric, I gave an example of revenue per user here. So as you see here from this histogram or the distribution of revenue per user, most of the values are clustered at 0. This could happen because not all the users will convert or make a purchase during the time frame of the A/B test. And that is why for majority of them, this value would be 0. Now, if you follow a traditional t-test in terms of calculating the significance for this kind of metric, it might not give you the best result. Like it can be a false positive or a false negative as well, which we will talk next. But in terms of what's a two-part test, as from the name, two-part test is a combination of two tests where the statistic is defined as the square of statistic is defined as the z statistic. First of all, the first part is z statistic, it's the square of z statistic. And the second part is the square of another test. And now this test can either be a t-test, a Kolmogorov-Smirnov statistic, or a Wilcoxon-Rank-Sum statistic. T-statistic is a parametric test, whereas the rest of them are non-parametric, so you can choose either of them. In our use case, we went ahead with a t-statistic. Now, once you have the squared statistic, we can compare it with the CDF of t-test to compute the probability. For this, we use inspiration from a paper for which the link has been provided. So all the instructions given in the paper were followed to utilize the power of this test. Okay, so we talked about different kinds of tests, but which test is better for the zero inflated data set? That can be decided based on the sensitivity analysis. Sensitivity is defined as ability of a test to detect an actual change. So here, what we did was we simulated some A/B tests wherein we uh, created a percentage change in revenue per user ranging from 0.2% till 2%. And we took different sizes of the population as well, or the sample size, uh, from as low as 1 million to up to 5 million. Now, then we compared the two-part test, t-test, and Bayesian test for this use case. And as you can see from the chart, that the two-part test, in all the scenarios, two-part test has a higher sensitivity than the t-test or the Bayesian test. The overall average sensitivity for two-part test observed here was 91%. T-test was having a sensitivity of 88%, and Bayesian test was having a sensitivity of 87%. Another interesting thing to see here is that after the revenue per user change of 0.65%, Bayesian test started performing better than t-test. But revenue per user as a metric is very difficult to move in real world scenarios. So most of the A/B tests which we conduct have a less change in the revenue per user, like lower than 0.65. So then in those cases, we can say that two-part test is rank 1 and t-test is rank 2. Now this two-part test is used only for zero inflated data set, like for metrics which have zero inflated value like revenue per user. For other types of tests, as we talked before, z-test and t-test are used. Coming up to the last section, how to choose recommendations algorithm offline. So here is an example from one of our latest research papers, uh, where we were deciding the best recommendation algorithm for the online A/B test. So the framework which we developed was able to predict the direction-wise online performance with statistical significance, given a caveat that the increase in offline metrics is significantly high. So as part of this framework, we constructed an offline evaluation dataset using the user's interaction with the recommendations. These user interactions could be add to cart, remove from cart, or any other signals which the user is having with the recommendations you give. In order to measure uh, the impact on business metrics, we created the custom offline evaluation metrics. Uh, like I showed before, the cart value impact, upsell, downsell. And then we compared some actual online A/B test with the offline tests. So mainly we looked at three live experiments. So we compared the online metrics from three live experiments with their respective offline metrics to come up to this conclusion. So as you can see in this table, apologize for a lot of numbers here, but here we see that for these three experiments, for the first two, you see that there was a, a positive change in the offline metrics. And then we also observed a significantly positive change in the online metrics as well. In the second one, you see that the increase in offline metrics is not that high. And hence, in the online metrics, we could see significantly positive result in only one of the metric. In the third A/B test, the increase in offline metrics was minuscule, and hence we could not see any significant results in the online metrics. And that is why we came up with this conclusion that only if the increase in offline metrics is significantly high, we can observe a positive or a negative change in online metrics accordingly. As of now, this threshold which we are talking about is 2%, but we aim to refine it using more A/B tests. Now, coming up to the conclusion. So, offline evaluation can be done to reduce the time taken to iterate through algorithms, and they also help us to reduce risk to the business metrics. Whereas online evaluation can be done using the best model selected via offline evaluation. So we are trying to minimize the risk to the platform, to the business metrics, to the user experience. And we are also trying to come up with the best algorithm offline before we conduct an online evaluation. Now, when we do online evaluation, it's important to follow some principles while designing an A/B test. And last but not the least, we should choose the correct statistical test while calculating the significance. Yeah, that's it. Thank you. I hope this was helpful to all of you.